Good evening, dear students. We are back to another session of our online class. I had already started thermodynamics, which is chapter 8 for class 11. And last time I already sent some notes, some basic notes. And I hope that you have gone through those notes. So in today's class, we will be deriving some important equations, especially related to expansion and compression of gases. Okay, first we will focus on this first law of thermodynamics. Okay, thermodynamic system, very common word. This is what a system. The best example I can give you is a gas in a container. Imagine here is a container and the container is filled with gas. Imagine that these are the molecules of gas. So, such collection of gas molecules can be called as a system. Sometimes we call it as thermodynamic system. So one main characteristic of thermodynamic system is that this collection should be able to produce certain value of pressure. It must exert pressure, and all of them should be able to produce volume V, and it should have its own temperature T. Then this collection of different particles can be called as a thermodynamic system. Okay, in the first law of thermodynamics, we will write this equation. Delta Q is equal to delta U plus delta W. This is the first law of thermodynamics. The meaning of the equation is, if you have a thermodynamic system, this is the system, you supply some amount of heat. Heat is supplied. The amount of heat supplied is delta Q. Then once you start supplying heat, internal energy of the system, delta U, we call it as internal energy, which is nothing but sum of KEN, potential energy of the molecules. These are the gas molecules. When you combine the kinetic energy of the molecules and the kinetic energy of the potential energy of the molecules, this will give you internal energy. So when you supply heat to a thermodynamic system, internal energy will increase. This will increase. Then after increasing the internal energy, the system will start performing work. This is denoted by delta W. Check it out. So go. Okay. So this is given by the first law of thermodynamics. Whenever you supply heat to a thermodynamic system, internal energy of the system increases. After that, the system starts performing work. This is the equation, that represents the whole process. And as I said, internal energy of a gas is equal to sum of kinetic energy and potential energy of these molecules. Do not forget that. Internal energy this is equal to sum of Ke and Pe of the molecules. Alright, this is the one, a brief introduction of first law of thermodynamics. There will be so many applications of this. Okay. After this, we'll talk about different types of thermodynamic process. In chemistry, you will be learning this also. This thermodynamics. There is a chapter, though I don't know what is that chapter number and all. Okay, then there are certain variables, say like pressure, P can change. Say this is a container, you put a gas here. This is the gas. You compress the gas or you expand the gas. When you compress the gas, pressure changes, volume V changes, temperature also changes. So during compression of a gas, what happens? Pressure increases, volume is decreasing, temperature increases. It means during compression or expansion of a gas, these are the quantities that changes. So these are known as thermodynamic variables. Thermodynamic variables, sir. So these are the physical quantities that change during a thermodynamic process. So what are these thermodynamic variables? These are the physical quantities that changes during thermodynamic process. So examples should be like a pressure, volume and temperature. And there are different types of thermodynamic process. Thermodynamic process. During a thermodynamic process, example is like expansion of a gas. Expansion of a gas is an example of thermodynamic process. Similarly, compression of gas also a thermodynamic process. So during expansion or compression, that process can be of different types. Like the first one is, say, isothermal process. Or you can call it as isothermal expansion or compression, like that. So in this case, temperature of the gas must be constant. It means a thermodynamic process that takes place at constant temperature will be called as isothermal process. Let me write it. A thermodynamic process that takes place at constant temperature is called isothermal process. Then you have adiabatic process, very important, adiabatic process. Remember, in this chapter, you have to focus more on these two, isothermal process and adiabatic process. In this thermodynamic process, like this example, this is a gas. When you compress the gas, example, you compress the gas. As you know, during compression of a gas, volume should be decreasing, pressure is rising, temperature also rising here. It means when the gas is compressed, temperature is increasing here. But if you do not permit heat to flow out here, for example, say, generally, as we know, generally heat should be coming out here. But if you don't permit heat to come out, for example, say there is no exchange of heat between the gas and the surrounding, or between the system and the surrounding, then that type of process will be called as adiabatic process. It means in adiabatic process, there is no exchange of heat between the system and its surrounding. So we can write now a thermodynamic process that takes place when there is no exchange of heat, or you can say no exchange of energy between the system and surrounding. So this type of process will be called as adiabatic process. After adiabatic process, you have isobaric process. isobaric, isobaric process. Number 3 is isobaric. In this process, in this thermodynamic process, the process must take place at constant bar, means that this pressure, it should be pressure. So we can write here a thermodynamic process that takes place at constant pressure. At constant pressure is called isobaric process. And you have one more. Number 4, isochoric. In isochoric process, the same thing you can write. A thermodynamic process that takes place at constant volume. Here, volume must be constant. So this is known as isobaric process. Isochoric process. So these are the different types of thermodynamic variables. As I already sent a note, this class, the class I am doing right now, this is for the explanation of the notes. And for the derivation, I need to take up in a separate class, as video session is very limited. I cannot record for longer hour because I have some problem in uploading. Then just go through one more time this one, and in the next class we'll derive this formula. So work done during expansion of a gas, we'll derive then. This will be integration of V1 to V2 VdV. This equation will be deriving in the next class. So this is for examination, especially for 3 marks, and it will be based on 2 processes. One is isothermal process and another one is adiabatic process. Okay, let me upload that video in the next class. Okay, just for today, we'll just stop here. And you please go through all the definitions again, the notes that I already sent to you before. Okay, then see you in the next class again.